Swayam Prabha. Digital India. Educated India.
My name is Professor Raghunathan. I am with the Department of Chemical Engineering at IIT Madras, and I am going to co-teach this course with Professor Shankar Narasimhan, also from the same department. Let me start by saying what data science is. Data science is a science of analyzing raw data using statistics and machine learning techniques so that you can get information out of this data. Why is there so much interest in data science? The interest is mainly because industries can make better decisions and data science is useful in a variety of application scenarios. However, doing data science requires the process of inspecting data, cleaning data, transforming, modeling, analyzing, and interpreting raw data. We also frequently hear this term big data. What does big data mean? Big data literally means large amounts of data, and when you have lots of data, there is this notion that if you had algorithms which are very powerful and sophisticated, you could use this data with these algorithms to make the inferences that were not possible to do before with smaller data sets. So extremely large data sets may be analyzed computationally to reveal patterns, trends, and associations which are not transparent or easy to identify. So there are these two concepts. One is a big data, the other one is data science, which talks to algorithms that can be used with big data. Now you might ask, is this all matter? Why is everyone interested in big data now? As you can see, big data is everywhere. Every time you go to the web and do something, that data is collected. Every time you buy something from one of the web retailers, your data is collected. Whenever you go to a store, data is collected at point of sale. When you do bank transactions, that data is there. When you go to social network, Facebook, Twitter, that data is collected. Now these are more social data, but the same thing is starting to happen with real engineering plants. Real-time data is collected from plants all over the world. Not only these, if you are doing much more sophisticated simulation, molecular simulations which generates tons of data, that is also collected and stored. So the point is that there is so much data of variety that is available. Now the question is, can all this data be used to do something useful, is what big data and data science is all about. You might ask, how much data is big data? For example, Google processes 20 petabytes per data. This is 2008 statistic, and similarly you can see the kind of statistics for Facebook, eBay, CERN, and so on. Now that we have talked about big data and data science, we might ask this question, why does all of this matter to engineers? It looks like most of this are being bandied about and talked in terms of social context. The important thing to note is, with engineering plans of the past, you didn't have lots of data, but with this new notion of Internet of Things, where you have information from anywhere and information from anything, not only do you have information from anywhere and anything, this information is also accessible, queryable, and organized. So this gives the hope that you could actually uncover interactions and patterns that were not possible to derive before. Now this is the context from engineering plants where lots of data is there. So we have big data in process industries, manufacturing industries, and so on. So again, what you need to do is be able to use this data with data science, algorithms for deriving useful information about the state of the equipment, process, and so on. Now the excitement is that there are all-weather algorithms for all kinds of problems that you can think about in data science, and some of these algorithms are self-learning and so on. So there's a lot of excitement about how to use these algorithms from an industrial perspective. So from a purely engineering viewpoint, you could think of using this data and data science for productivity, profitability, safety, and so on. Take the simple example of an industrial accident. If an industrial accident occurred 30 years before, that information is not going to transmit readily to people around that region. But in this day and age, if anything happens, this information gets transmitted in no time. So you can imagine the kind of safety that you can provide with information. So it is important for engineers to understand the notion of big data, understand Internet of Things, and understand data science, so that we can make our plants more productive, more profitable, and safer. So what is this course going to cover? It's going to tell you that collecting data does not mean discovering. So just having data does not matter. What you should be able to do is you should be able to use this data to lead to value propositions. So this art or science of converting collected data to useful knowledge is what is called data science. And whenever we talk about data science, there are these three aspects that we need to keep in mind. One is the domain knowledge. What domain are we using this data science for? So that's the reason why data science is important for mechanical engineers, chemical engineers, aeronautical engineers, and so on. However, there are lots of things that you can do without the domain knowledge in terms of the algorithms itself. So this course is going to be largely domain agnostic, and it's going to introduce algorithms for all kinds of engineers to use. So in terms of algorithms themselves, the two things that we are going to really spend time on in this course is the statistics and the statistical techniques that underlie these algorithms, and the machine learning techniques that are part of data science. There is also the software aspect of programming this data science algorithms. So we are going to use a particular software to demonstrate these ideas in data science. So if we were to look at the objectives of the course, this is going to be a first simple course on data science. We want to introduce participants to a programming language that they can use with this course. We will introduce the participants to the mathematical fundamentals from a data science focused perspective. Some of these you would have seen in your core courses in your colleges, but what we are going to do is we are going to take the same material and approach it from a data science perspective, and then tell you why what you have learned is important from a data science viewpoint. Now data science means many things for many people, so we are going to give you a framework for understanding data science problems. This is what we call as typology of data science problems. And again, there are many data science problems solved in different ways. So we would like to give you a conceptual framework for solving data science problems, so that you can apply the same kind of thought process to multiple problems. We will teach commonly used data science algorithms and give you a practical orientation at the end through a case study which you have to program and solve. I also want to emphasize that before this course starts, we are going to give you pre-course material on R, which is going to be the programming platform for this course, and we would expect you to have worked through that prior to attending this course. This is a more detailed outline of this course. So there is a section on what is the programming platform that we are going to use, and in terms of fundamentals, we are going to have two major blocks. One is on linear algebra and how is it useful for data science. The second block is statistics and how is it useful for data science. Then we are going to talk about the typology of data science problems and provide a solution framework. And most data science problems can be either categorized as function approximation problems or classification problems. We are going to teach regression as a framework for solving function approximation problems, and we are going to show you some well-known techniques for solving classification problems. Now that is the outline of the course. Once you are done with this course, what do we expect the outcomes of the course to be? In other words, what can you do if you do this course well? First, you will be able to describe a flow process for any data science problem that you come across. You will be able to classify data science problems into standard typology. You would be able to use R as a programming platform to solve data science problems. And once you program and get some results, then you will be able to correlate the results that you get to the solution approach that you follow, which will help you assess the solution approach. And in cases where you are not happy with the solution approach, you will be able to do modifications as required. And finally, this course is the first fundamental course on data science, which will be a prerequisite for more advanced machine learning course that will follow this course. Now, from a purely job viewpoint for students who would wish to take this course, I just want to point out that data science is just not a buzz. There is going to be a lot of demand for this. The demand is supposed to grow 30% year on year in India, and at the end of 2020, people expect about 220,000 jobs to be available in this area of data science. These are interesting jobs, well-paying jobs. So it's a good idea for engineers to be geared up for taking advantage of this opportunity that is going to show up, or it's already shown up now. Thank you. I hope to see you taking this course next year.